Hello, there is Impossible Creations, and in this video I will describe different parameters and stuff which are inside Tail Animator and how to use them. Let's start with the most basic stuff. Tail Animator is animating bones, in the most cases, like it's described, but bones are represented in Unity by game objects, so there is not much magic. So you can just create simple structure of game objects, each model is child of another. And when we add Tail Animator to first, it will animate this chain like a tail. And you do the same thing with bones. Now, there we have simple tail model with Tail Animator attached to it. Let's begin describing inspector window. Each parameter have tooltip to help you, but I will try describe them more in depth and with examples. First field is tail list. When we add Tail Animator and do nothing with this, tail chain will be created automatically from this game object and its children. There is tooltip which says autoget to inform you what will be done. When we hit plus and assign here one bone, tail chain will be created from this bone and its children. We can untoggle this to create chain only from one bone. Or when we hit plus more and assign new bones, then tail chain will be created only from these bones. When we have enabled auto getting, tail chain will be created when game starts, but we can hit auto to create it in edit mode. So here we have all bones / game objects which we will animate. That's all about tail list. When you toggle this, you can see in scene view on which bones tail chain will be created. Toggling this will hide bottom graphic. There we have toggle root to parent, but we will talk about it later. Now animation parameters section. With these parameters we will shape motion of the tail or anything to which we apply this component. Position and rotation speeds are defining how rapidly segments should react to changes. They are influencing all other parameters. In most cases, default settings are just right, but you can play with them as far as you prefer. Springiness is making motion bouncy. Position and rotation speeds can't be set too low to see this effect. Springiness can add some meaty feeling to the tail. Next parameter is sensitivity. It can help amplify springiness, but can be used for other purposes. You can make tail more stiff when you go lower with the value, or make it more sensitive and aggressive for the changes by going up. But be careful with it. Each model can have own sensitivity factor when you are cranking this parameter up. It depends on the bone structure. Next one is max stretching. It's allowing object stretch when it's moving very fast. It's right to stretch a little. It can help motion to have more smooth feeling, but it should be limited to avoid situations like this. So when we go down, an object moves very fast, stretching is not noticeable. But also you can leave it pretty high for more toony effect. Last one is angle limit. With it we can lock tail to not rotate too much in direction we don't need. All rotation axes are limited when we not assign any axis to be limited. When we assign it, then it's limited symmetrically. Now we can limit one side of axis with a slider. In some cases it can be pretty helpful. Another section would be updating order, but we will talk about it later. Now let's focus on waving options. This option just enabling rotating first bone in chain in a wiggly tail manner. It's rotating with mathematical functions. With simple option, it's basic waving animation. With cosinus addition, there's less regular motion. You can define how quick it moves and how much. You can also define which axis should be rotated. Or offset first bone rotation. You can change option from simple to advanced. Then rotations are animated with Perlin noise, so it's much more organic. Alright, about tuning section we will talk later. Now physical and experimental tail section. We can start with the most simple parameters here. With curving parameter, you can change shape of the tail in a quick way. You can use gravity parameter to simulate force put over the tail. Combine it with waving to give tail motion like it's on the wind. Stiff tail end is just making last segments more rapid. It can help when you have very long tail with a lot of bones. Now collision option. When set it up correctly, it will simulate collision of tail with other colliders. It's very useful addition to the tail motion. First, you should select collision space. World space will give you collision with everything which have collider. It uses rigid bodies added to each segment of tail, so you can use collision layers if you need. Also, tail should have assigned new layer which is not colliding with self to work more optimal. In world collision you have possibility to choose avoidance method. It's during development and in future this option probably will disappear and the most efficient method will be used by default. You can check each of them to find one which work the best in your project. Second collision space is called selective. There you can drag and drop colliders you want to collide with. This method is a lot quicker and more precise than world space collision. For now, I recommend using that even you have many colliders to collide with. Now, when we know which collision space we want to use, we have to define scale of the segments colliders. You can use different parameters to make colliders fit to the model. We can use curve to make colliders go smaller when tail is getting thinner. I will describe collision swapping variable in a play mode. Now let me show you this in action. So we're moving tail towards platform and it collides. Now about collision swapping. Although this parameter will probably disappear in future versions, but now can be helpful. When we go lower, collisions are reflected instead of swapping to the ground. It can help in exception situations. For example, when you put additional gravity force on tail, then you can make it react better. Now let's go to update order options and tuning tab. Let me show you this in play mode. When your creature is animated, update order will not work. It needs to be set as late update to apply tail motion after Unity's animator. Otherwise, Unity's animator is overriding our tail motion. Let's go to tuning tab. You can use stretch multiplier to make tail longer, but this option have nothing in common with max stretching variable. When you untoggle full correction, there will be used simplest variant of animating tail by tail animator. It will not work on tails which initially have very complex shape. Script will try to make them go straight. When we enable full correction, shape of tail will be intact. When we enable animate corrections, tail animator will try to follow module animation and add its own procedural motion to it. But if your tail don't have animations, this toggle should be disabled. It could produce glitches like this. Last thing we have here is lookup method. It's algorithm which should be used by tail animator to automatically fix tricky setups of tail bones. When your tail after enabling tail animator looks something like this, try changing lookup method. One of them must work, or just change to parental. It's the most universal algorithm. It's not set it up as default because it needs some more testing. Now let's go back to root to parent toggle. This toggle is making tail reference motion rotations hardly from its parent. It can give you more desired effect. And check how it reacts when it's disabled and enabled. Thanks to that option, we can use tail animator on single bones. And this option needs parental lookup algorithm, but it's switched automatically when we enable root to parent. Now let's go to tail animator blending component, which have some extra parameters to help work with animated bones. Button connect with animator is toggling variables for animate corrections which we were describing moments ago, so nothing magical. And then we have toggle rotations not animated. In some exception situations, After enabling animate corrections, one bone can be glitching. Then you can toggle rotations not animated parameter, find which bone in chain is one which is glitching, and toggle it. That's because this one bone wasn't animated at all. There we have parameter blend to original, so you can define what amount of tail motion should be used over the model animation. And final thing is skinner component, which is allowing to skin mesh renderers inside Unity editor. It's only for simple purposes, but can be very helpful. So you add this component to the model you want to skin, make it fit to the model, define how many bones you want to use, then you can set how weights should be spread, then hit button skin it. New skinned model appeared next to this one. Let's check if everything is working. Inside models directory there is created asset which is holding skinned mesh renderer. And that's all for this explanation video. If you have some questions, please write it in the comment section. Please leave a like if you enjoyed, subscribe for more, hit the bell for notifications about new videos, and see you next time. Bye bye!